Hello everyone. Today we are going to solve the question on 2-sum. If you are watching this video, I am expecting you are new to Leetcode, otherwise this video is not for you. So without further delay, let's get started. So our question says, given an array of integers, nums and a target, return indices of two numbers such that they add up to target. Okay. You may assume that each input would have exactly one solution and you may not use the same element twice. Okay, so for example, if our array has 2, 7, 11 and 15 and our target is 9, we can see that 2 and 7 give us 9, right? What are the indices of 2 and 7? 0, 1. Coming to the second example, if our array is 3 to 4, target is 6, you can see that 2 and 4 give us 6. The indices of 2 and 4 are 1 and 2. So this is pretty much what our question asks. Now let us look at how to solve it. Okay, so let's take the same example from the question. We had 2, 7, 11, 15 as our array and we need a target of 9. Now, the first intuition that comes to our mind is, what if we try the combinations of all these numbers? By combinations, what I mean is, what if I try this combination 2, 7, then again with 2 I can try 11, right? Again with 2 I can try 15, with 7 I can try 11, 7 I can try 15, right? 11 I can try at 15. Now 7 2 is not a different combination because in this case we just need the sum. So 2 7 7 2 give us the same sum. Okay, so the intuition that has come to our mind is not wrong, it's right. But the question is, how do we find out all these combinations? Because if we can find out all these combinations, we just need to check the sum for each combination, isn't it? We just need to check what is 7 plus 2, what is 11 plus 2, what is 15 plus 2. If it matches our criteria, if it matches our target, we have the answer. Now let us think about how do we find out all this question. The answer is using two for loops. Yes, you have heard it right, using two for loops. How does that work? Let me show you. We'll have one outer for loop, okay, that will run from 0 to the second last element of the array, that is 2. We'll have an inner for loop that will run from I plus 1 to the last element of the array. Now you might ask me, why is this happening? Why is I running from 0 to 2, j running from I plus 1 to 3? The answer is in the question itself. Okay, now see, if I ran from 0 to 3, that is the last element, if I ran from 0 to 3, then our j always starts from I plus 1. Now if I is at 3, okay, if I is at 3, then j will start from 4, which does not exist in the array. So the answer for this lies in this statement, okay, that j start from I plus 1. So this is why you have to run I from 0 to 2. And regarding why j starts from I plus 1, it is because the question said you cannot repeat the same element twice, okay. So if I have used 2 once, I cannot use it twice. This is the reason. If I am at 2, my j starts from 7, okay. If I am at 7, j starts from 11. Because otherwise, let's say if your target was 4, okay, then you would have said 2 plus 2 is equal to 4. This is not right because 2 is only present once. This is why. Think about it, you will get it. It's not that difficult. Now without further delay, let us directly look at the code, and later we'll take a look on what is the time complexity. Okay, what is the time complexity and what is the space complexity. Now let us look at the code first. We'll come back to this later. Let's start with the coding. So we'll do exactly what we have discussed. Our loops one will start from 0 to the second last element, and the inner loop will start from I plus 1 to the last element, okay? And then we'll have a logic inside it. The logic is simple. If nums I plus nums j is equal to target, then return our answer. Now in the answer we have to return a vector, so we can return a vector like this that will contain I and j. We also have to add a return statement at the end because this is a non-void function. This is returning something, so our code will complain if we don't use this return at the end, because our code won't come up to line number 9, isn't it? Think about it. We'll get an answer, we'll get some answer here, then it will return the indices from here itself, line number 6, so it won't come to this position. That is why you have to write a return statement here explicitly. You can try it out without writing return statement and then submitting. Now let's submit the code. Yes, it has passed, but as you can see, runtime is quite big. Let us look at the time complexity and how to improve it. Now that we have solved our equation, let us look at what is the time complexity for it. So the time complexity is going to be big of n square. Why big of n square? And regarding big O, this is known as asymptotic notation. Okay, this is a way of representing the time complexity of our algorithm, and it is big of n square because we are running two for loops, right? Both of these for loops run from first to last of the array, so big of n into big of n, it is big of n square. And regarding space complexity, we don't need any extra space to solve this problem, so it is big of 1. But mind you, this is not the most optimized solution. This is known as a brute force approach, okay? Because this is not the most optimized approach. So now let us look at how to solve it in the most optimized approach. Okay, so now let us look at the same array again, and let's see how to solve it in an optimized way. Now see, we'll solve it using a data structure known as map. If you are not acquainted to map, don't worry, we'll learn about map in this problem. So what map does is, map stores data in the form of key value pair, okay? Key value pair. So I can do something like, I can store, let's say we call our map MP, okay? I can store a key. Let me use the array numbers as key here. So I can say map of 2 is its index. So this is the key, this is the key, this is the value. I can say map of 7 is 1, isn't it? Map of 11 is 2, map of 15 is 3. Now how is this map going to help me in this problem? This is how. See, let's say we start iterating this array from the left, okay? And once you come to 2, what you can do is, now since your target was 9, right? Target was 9. So what you can do is, you can search like, is 9 minus 2, that is 7, available in the array? It is available here, but you actually don't know yet, right? Because you are iterating from the left and you have just come to 2, okay? So how to search this? Is 9 minus 2 equal to 7 available in the array? We'll check if it is available in our map, okay? If it is available in our map. But since we are iterating from the left, we don't know yet, okay? So now let's come to 7. Now we'll check, is 9 minus 7 available in our array, that is 2? Yes, because we already have encountered in our array that 2 exists. Because every time we iterate a number, we'll store it in the map like this, isn't it? So when you started iterating from the left, we have stored this map of 2 is equal to 0. We have stored this in our map. So now if we check, when you come to 7, if we check, do we have 2 in the map? Yes, we have. And that's our answer. So this way you will just need one for loop. So your time complexity is going to be big of n, isn't it? You won't need 2 for loops now, and this time you will require a little bit of space. By little bit I mean big of n, because in the worst case scenario your map is going to take n numbers. Yep, so see, this is quite a big improvement from big of n square to big of n, right? So without any delay, let's see how the code looks. Okay, so let us implement the map algorithm like we just discussed. So for that, first we'll declare a map. So this is how a map is declared. Map of int. So this int on the left denotes the key, int on the right denotes the value, and let's call it empty. Then we'll require one for loop to iterate the array. So this goes from I equal to 0 to I less than nums.size. I'm hoping you are acquainted with this for loop syntax. And now for every number, what do we check in the map? We check if, this is how you check if a number exists in the array. If a number exists in the map, sorry, what you do is, if map dot find, okay, what are you finding? You are finding if target minus nums I exists, and after find you need to do this, not is equal to map dot end. This is how you search something in a map. You basically ask the map, can you find this? Can you find target minus nums? And this is the syntax how you write if map.find not equal to map.end. So if this is true, if this for loop is true, then we return our answer, as simple as that. We return a vector again, but this time what do you return inside the vector? You return I, okay, one index and the value in the map. For, let's say you had 2 and 7, right? So when you come to 7, you return 1, I is 1, and map of target minus nums I. What will map of target minus maps I contain? 0, right? Because map of target minus nums I is 2. So MP of 2 is 0. So just return this. And like and also if this if condition does not run, then we don't have to do anything, just store the number itself in the map with the index as a value. Just compare with the solution discussed earlier, this will be clearer to you. Just do this. Yep, so this is our working code just like we discussed. And now let us do one thing. Like I said earlier, you have to return an empty array because this is a non-void function, okay? So yeah, that's pretty much it. You run a for loop, you check if the number exists. If it exists, well and good, return the answer. Otherwise, just mark the key value pair. Just store that this number. See, in this statement, we are just storing this we are just storing that this number exists, right? Think about it using a pen and a paper, you'll get it. It's not that difficult. Yep. Now let's run the code and see what happens. Yep, it ran, and as you can see, it came down from 500 something milliseconds to 21 milliseconds. Yep, so that's it. Keep watching for more solutions. Thank you.